So after the fire, what goes away is the one single component that is holding the place together, and that's the vegetation. Because of these deeply weathered soils and granitic origin, we've got a situation where once you remove this, and if it's a higher than normal severity fire, you're going to get more of that than you would in a historical regime where you had spotty fires all the time. You're setting yourself up for a large percentage of any given watershed being denuded, being taken down to granitic soil. While that happens, you're removing the sponge that lays on top of the ground. You're removing the organic soil cover. And we saw this, we've seen this in almost any vegetation type, in that the soils, once you pull that ground cover off, it loses its protection from rain splash. It loses a frictional component that inhibits high speed surface flow, high velocity flow. And it ends up leading to concentration of flows. And what you get right across from us is one of the gullies that formed here in Rye Creek. We call them debris flows. Most of the debris flows that happen in these post-fire situations occur 15 minutes, 30 minutes long, and they're done. But they've moved literally thousands and thousands of cubic yards of material in 15 minutes in any given drainage. And because these things have been going on for so long, this whole routine is natural, except for the high severity part, which I can talk about a little bit more. We build up these fans at the bottom, which is that V-shaped situation over there where it's kind of filled in, it's a little bit less steep, and the gully will cut a channel one side or the other in that. In fact, Karin pointed out there's 2 channels in that one. So alluvial fans are a natural phenomena. The stream will cut against the bottom of it over time and remove that material, send it downriver.
So I want to go back to the debris flows for
Go ahead.
just a second, just because I studied these for my dissertation.
Yes,
so
let's hear about it.
I think they're kind of cool, and Ed did a really good job, so I don't really have much to add. But one of the things that I think is kind of cool to realize about them is in these kind of areas, they are responsible for most of the erosion. So there's some studies indicating that the amount of sediment that's going out daily in a stream is about order of magnitude 10 times less than what gets delivered in these episodic events. So these debris flows are the major driver of topography here in a lot of ways. And after you've walked around on enough of these debris flow pans, you start to notice how they form the stream course in a lot of instances, especially where we've seen a lot of them recently. The stream is making its way around the toe of all of these debris flow fans. And another thing I realized after walking around on them for a while, and I don't want to get into Mike's topic at all, but people regard these kind of like fire, as in this is a disaster, this is not a good event, this is a bad thing for the watershed. And maybe that is true in the short term, but you also realize that it is bringing down the larger rocks that we know are good for fish now, and then when you have a fire on top of that, it's delivering large woody debris to the stream.